Welcome to our YouTube video. Today, we are delving into the fascinating world of clock skew and its impact on both performance and manufacturing in VLSI chips. Whether you're a tech enthusiast, a design engineer, or a curious learner, this video is packed with insights that will leave you amazed. So, let's dive right in. Clock skew, the variation in clock arrival times across different parts of a chip, is a critical factor that affects chip performance and manufacturing. While we often associate clock skew with performance issues, today, we'll uncover its profound role in manufacturing and scan-based testing. Scan-based testing, the most popular structural testing method, plays a pivotal role in detecting manufacturing defects in chips. However, this testing approach relies heavily on minimum clock skew to ensure error-free shifting of scan vectors. By reducing skew, we enable smooth propagation of scan vectors through the scan chain, making it easier to detect stuck-at and delay faults in the circuit. Hold failures, especially at the best-case process voltage temperature (PVT) corner, are common in circuits with limited or no logic gates between the output of one flop and the scan input of the next flop in the scan chain. These hold failures can negatively impact chip manufacturing, leading to yield and reliability issues. Here's where managing and reducing clock skew come to the rescue. By carefully designing the clock distribution network and minimizing clock skew, we can effectively address these hold failures. Reducing skew ensures that the setup and hold times of flip-flops in the scan chain are well matched, enhancing the overall reliability and manufacturability of the chip. It's crucial to strike the perfect balance between performance and manufacturing considerations. A well-tuned clock distribution network not only enhances chip performance but also improves the efficiency of scan-based testing during manufacturing, resulting in higher yields and faster time to market.